Hi there, I'm John McMillan, and welcome to this special series of PCB Tech Talks, the After the Webinar series. In this special podcast series, I'm joined by webinar presenters as we answer and discuss the questions submitted by attendees that were answered live during the webinar and the questions submitted that we didn't get to during the allotted time. Today, I'm welcoming back Shivani Joshi. Shivani is a technical engineer, author of a very popular ABCs of PCBs blog series, student advocate, and the demo presenter of our most recent signal integrity analysis webinar entitled, Your PCB Designs Need SI Analysis and You Don't Need to Be an Expert. So, if you attended one of our events live or watched the recording on demand, some great questions were asked, so let's get the answers. Hi Shivani, welcome back to PCB Tech Talk.
Hey John, thanks for having me on the podcast. I'm excited to be here.
Well, we're excited to have you back. So we got a nice collection of questions, particularly from the European session, but the US session had some really good ones as well.
Yeah, we got a ton of great questions during the webinar, and unfortunately we weren't able to address them live. So take some time now and get all of your questions answered.
Absolutely. I'll take the first one. There are several things that can indicate the potential for SI issues. High-speed signals, for example, high frequency, long traces becoming transmission lines. So naturally, if your design is high speed, has differential pairs, issues with EMI, crosstalk, signal reflections, and if you discovered things like ringing on a fabbed PCB, it needs to be analyzed for SI to catch, correct, and avoid respins. So if your design has DDR SerDes, for example, those certainly need SI analysis. Many issues are actually difficult, if not impossible, to identify during manual prototyping. So for example, the case of an issue like ringing, for example, would have been very difficult with just measurements alone, like finding a needle in a haystack.
So this is a question that we get quite often. What is the use of checking signal integrity on a PCB? I think that's very valid since there are people that don't run these checks, but you kind of have to just think, like sometimes signals run into some sort of interference and you might not know that until you've already produced a board. So running these signal integrity checks on your PCB earlier in the design process will usually help with reducing the time to market and will likely give you fewer respins. Plus, you can always make sure you're producing the quality board that meets your requirements because you're able to do these analyses in a software setting versus physically once the board is, in front of you.
I'll let you address this eye diagram question.
There were actually a few questions about creating eye diagrams, specifically for DDR type of analyses. And yes, you are able to, take on DDR design challenges in PADS Professional. We actually have a great webinar that covers this topic, thoroughly. So if you actually go back into the pads.com resources page and you search DDR, you'll find this webinar, and it covers all these design and analysis capabilities within PADS Professional and helps you walk through, what you're able to accomplish with that.
Good question. I'll take the next one. What about things like high-speed nets crossing split planes? Does SI catch those? That's a good question. So you'll actually want to run electrical DRC on your designs to discover any layout electrical DRC issues like nets crossing gaps. I won't go into the details here, but we actually have a electrical DRC specific webinar that is available on demand on pads.com that will take you through that. So I'll actually include a link to that on demand webinar in the show notes.
So can I share these hyperlinks files? The answer is yes. So Hyperlinks LineSim allows you to open .ffs files, and Hyperlinks BoardSim will open up .hyp files. And you can share these with other users using hyperlinks. But if you want to share with other users outside of that, you can always save and review and share the batch analysis report, which we covered during the webinar.
Good answer. I'll let you take a couple more.
So a couple other questions about coupled nets. So a lot of people were asking what was the use of coupling segments when you're exporting to LineSim. And, that just kind of helps when you're going into layout. So if you recognize that nets might be closer together when they're in layout and might reflect a coupling effect, it's usually just good practice to simulate them as a couple net so you're clear of the results that you'll see when you go into layout. So we had another really good question about electromagnetic interference and simulating that. I realized I didn't actually go over that in the webinar itself, but you can run EMI tests. So when I had gone through and run a batch analysis on the Crosstalk, you could have selected EMI testing as well. And so you'd have a batch report that went through and analyzed what you needed to in the EMI space.
Okay, I'll take the next one. What are the cost savings in performing SI analysis that my manager needs to know about? And that's a really good question. I've seen some comments on LinkedIn posts actually from PCB designers asking this. The cost savings is big when you consider the cost of a design respin. Managers are typically very interested in meeting manufacturability, cost, and time to market goals, especially in competitive markets. So imagine eliminating a prototype build used to identify issues and the added cost in design rework and the additional board spin. Also, imagine a PCB design to production fab cycle that has it set to 12 weeks that can be reduced to 8 weeks because, you eliminated a prototype. That's 4 weeks of a designer's time that could be spent on other projects. Achieving first pass design success should be the goal, but eliminating even just one prototype build is huge. Back to you, Shivani.
So here's one. Does signal integrity analysis tell you the exact length of a particular trace? So yes, you can actually test out the proper length for your trace to make sure that you're getting your desired results. One great way of doing that is running the Terminator wizard, which we did in LineSim, and that gave us a suggestion on your trace length. It'll let you know if the trace is too long or too short, so that you're prepared when you go into layout.
Yeah, why don't you take another one?
What does excessive crosstalk look like? So that's kind of a hard question to answer because crosstalk limitations are really dealt on a case-by-case basis. So too much is really just defined by your application. We typically say that, you want a maximum of about 5% over and under your signal. That's usually a good range. But for high-speed signals, that swing is significantly lower, usually closer to 0.3 to 0.5% over and under your signal.
Okay, I'll take this one from the North America session. Your examples are all 500 megahertz. What is the highest frequency you can use in PADS Professional? Running simulation hyperlinks, I'll say it depends on what kind of models you are using. Different components of hyperlinks have different degrees of accuracy, but the combination of our built-in trace models and the full wave solver allow for accuracy up to the 500 gigahertz range for your PCB structures, while also allowing for the most efficient analysis time.
So another great question, when should I be analyzing signal integrity, power integrity, and thermal analysis? So these type of analyses, they lend themselves perfectly with the modern left shift design methodology. So that just means you're not, analyzing in a linear flow. You're analyzing throughout your entire design flow. So we're doing signal integrity analysis in pre-layout to make sure things like the trace length, the width, topologies are all, designed to succeed in your layout. And then we also do these analyses in post-layout to make sure everything is validated before sending off to manufacturing, making sure everything's all set and ready to go. So we had a few people ask, what type of signals should I be conducting SI analysis on? And honestly, you can conduct the signal integrity analysis on any path that you'd like, but you may want to take exceptional care of any of the high frequency signals because they usually will cause the most signal integrity issues. So just to keep that in mind as you move forward with your designs.
I was excited to see the number of academia folks on the call. You're not so far out of school yourself, Shivani. I'll let you speak to that.
So we actually had a couple of college students that joined the webinar, which was really exciting to see. And they had a lot of questions on just how to get started with PCB design. And I want to first and foremost say welcome to the PCB world. I know that it can be a little overwhelming, so I would just suggest reading through some tutorials and some basics. When I first started, I went through YouTube to make sure that I was understanding the concepts, before I started diving into a design. And if you want to just test out your PCB skills, you can actually use our free PADS Professional Student Edition. That actually comes with a workbook, so you can create a flasher PCB design. And there's so many more resources that come along with that tool. So you'll have access to a YouTube series that shows you step by step what you're doing in the tool. You'll have access to Support Center, which is where all of our resources for our support team go. So, you might want to take a shot at that. And honestly, if you think you can create a design, I would recommend sending it to us through the PADS Professional Student Design Competition. Get your chance to win some Oculus glasses. Kind of exciting, something to do, something new to try.
Well, that wraps up the Q&A. Thanks, Shivani. It's always a pleasure having you on PCB Tech Talk.
Thanks for having me on, John.
And I wanted to thank you for joining us for this special After the Webinar series podcast. For more information on this podcast, as well as a link to the on-demand replay of the webinar discussed, be sure to check out the show notes. There you'll also find additional information related to this podcast along with my email address. So feel free to send me your comments and questions or any topic you'd like to hear us discuss, or if you'd like to be our guest right here on PCB Tech Talk. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, iHeartRadio, Stitcher, or your favorite podcast app. And be sure to catch the next episode of PCB Tech Talk.